Welcome to Unit 1, Day 4. These are going to be solving absolute value problems. We're going to be largely seeing equations today with a couple inequalities. Whenever you're dealing with absolute value, what you're going to have to do is, if you have, that, say, the absolute value of x equals, let's say, 3, you would actually have two possible solutions for x. First of all, x could be 3, and this would work out true, that the absolute value of 3 would be 3. But the one that people often forget of is the negative value, that x could in fact be negative 3 and this still be true. So you're going to end up a lot of times with two solutions for this thing. Now sometimes it is possible for you to end up with one solution. An example of that would be, let's say, the absolute value of x minus 2 equals 0. So right here what you would see is that x minus 2 could equal 0 or it could equal negative 0, but that wouldn't make much sense because 0 is not positive or negative. So here x would equal 2, and that's an example of where you'd have only one solution. Alright, the last one that I want to address really quick is, let's say you have the absolute value of x plus 3 is equal to negative 5. Now, you would actually have no solution here, and the reason is because the absolute value can never give you a negative result. So you'd have no solution. It'd be the null set for that one. So this is example 1, and whenever you're solving absolute value equations, the first thing you're going to want to always do is get the absolute value by itself. I'll accomplish this by minusing the 5 from both sides. And I'll have the absolute value of 6 minus 4t equal to negative 5. Now, like I said, you would actually split the equation up right now, except in this situation, the absolute value equals a negative. And we know that can't happen. Whatever I get for the absolute value here, it's never going to equal negative 5, so t has no solution on this problem. You are finished. Now, here's where it becomes a little bit of a beast. The 8 plus y, it could equal one of two things. One of the things 8 plus y could be 2y minus 3, the positive version of it. Now the other thing 8 plus y could actually equal is it could have been negative 2y minus 3, because if it did equal this, when I throw that in here, it would have created 2y minus 3. Now I'm going to solve both of these equations and have both of my answers. On this left one, I'll subtract y on both sides, so I get 8 equals 1y minus 3. I'll add 3 to both sides and get 11 equals y. That's one of my two answers. Over here on the right hand side, I will distribute the negative sign. And now I'll subtract, well actually I'll just add 2y here, so I'm dealing with positive. So I'll have 8 plus 3y equals 3. Subtract the 8, and I get 3y is equal to negative 5, so y is equal to negative 5 thirds. There's my two answers. So y equals 11 or y equals negative 5 thirds. Alright, at first this is going to seem like it comes in out of left field, that this shouldn't be part of this lesson, but it is tied to it. Compound inequalities are expressed with absolute values, and I'm going to show you that to you right now. This is a compound inequality where 3y minus 2 needs to meet two conditions simultaneously. First of all, 3y minus 2 does need to be greater than or equal to 10. So I'm actually going to write that as its own inequality. 3y minus 2 is greater than or equal to 10. And at the same time, 3y minus 2 also has to be less than 19. I'll solve these independently. So on the left-hand side, I will add 2 to both sides, and then I will divide by 3. Y is greater than or equal to 4. On the right-hand one, I'll add 2 again, and divide by 3. Y is less than 7. But both of these conditions have to be met. Y is any value greater than or equal to 4 and less than 7. But you could also write this as 4 is less than or equal to y, which is less than 7. That would probably be the way that you're going to most likely see me represent my answers, and I expect this from you. Now, I'm not going to get into too much depth here, but there is a basic understanding that you have to have. If you're dealing with inequalities with your absolute values, here's the rules. When the sign is greater than, you're going to use the word or, and you're going to make a compound inequality such as this. X is greater than 3, or and you might have seen where that one's coming from. X could be any value greater than 3. But there is a separate group that would also work here, that X could be any number less than negative 3. So you'll always get your first inequality from what you see. When it's greater than, you'll use the word or. And the second inequality will come from changing both signs, both the inequality symbol and the sign of your answer. And now for what happens when it's less than, pretty much exactly the opposite, you'll use the word and. Both conditions have to be met. So X is less than 3, you'll see that one, and X has to be a number greater than negative 3. So similar practice, you'll change both signs for the second one, but a key difference is that you're using the word and. As far as number lines go, to represent your answers, for this left one, it would have been starting at 3 and anything above it, and starting at negative 3 and anything below it. For this right one, it would be anything between the two values of 3 and negative 3. So a huge difference whenever it comes to getting your correct answer here. So now I'm going to apply that to this inequality, and what's going to happen here, you're going to want to actually take this expression and set it greater than 9, and I'll go ahead and write that out. Also, too, forgot to remind you of this, you'll want to solve for the inequality first before you start splitting it up like I am. So 3x minus 3 is greater than 9. Since it was the symbol greater than, I'm going to use the word or. And I'll have 3x minus 3 would be, and here's where I'm going to change my sign. So less than negative 9. All right, go ahead and solve both of these. Starting on the left, I'll add 3 to both sides, and I'll divide by 3 to get x is greater than 4. Or, and over here I'll do the same process. Adding 3 will give me 3x is less than negative 6. Divide by 3, x is less than negative 2. And it does say graph our solution on a number line. So I have two distinct groups of numbers. One of them's less than negative 2, open circle, shading to the left. The other is greater than 4, open circle, shading to the right. And there's my correct answers. This is what I'm looking for. Okay, working through example 5, I assume that you can pause this and actually read through the problem. What we're doing here is we're going to write an absolute value inequality to describe the situation. I'm going to use X as her actual salary. Really common problem for absolute values is to see one like this. Now, here's the deal. There's going to be a difference between her actual salary and the $38,500. Now, that difference could be 0 because she could actually get paid that, but she can get paid higher or lower than that. And here's how we're going to represent it. The difference between her actual salary and $38,500 has to be kept within absolute value, less than or equal to, because it could be by as much of a difference of $2,450. The difference between her actual salary and the $38,500 has to be within this amount. That way, if her salary is above $38,500, the absolute value would effectively just keep it positive, and it has to be less than this. If it's less than the $38,500, you'll be getting a negative value here, but the absolute value will turn it back to positive, and you still have to stay less than this. Now, let's actually go ahead and solve it. Actually, it just said to write it, but I will go ahead and do the extra steps of solving it. This would have been your answer for the way the problem was worded. Since it was the less than, I will use the word and. I will now have x minus 38,500, and it will be greater than or equal to 2,450. On both of these, I just have to add 38,500. I did make one small boo-boo. I forgot to change the sign on that one to negative 2450. So let me fix that. There we go. And now I'll go ahead and do these. Alright, so over here on the left, adding 38,500, I see x needs to be less than or equal to 40,950. So that would be the top end of what our possible salary could be. And on the low side, I'll do the same process of adding it over here on the right, and I'll get $36,050. Her salary could be as low as $36,050, as high as $40,950. Somewhere in between there is what she can actually prepare herself to get. Here's a very similar problem. So this has to do with error. So we're going to have an actual, the actual measure of the tennis racket. And it's going to set up similar to what you just saw, that the difference of the actual and the 100 square inches has to be kept within 20 square inches. And that would be my setup. Now I would, it did say to solve on this one, so x minus 100 would be less than or equal to 20, but we will use the word and. X minus 100 could be greater than or equal to negative 20, and I did actually change the sign there. I didn't mess up this time around. I'm going to go ahead and add 100, and I'll get 120 square inches is the largest that it could be. When I add the 100 over here, I'll get 80 is the smallest it could be. Now, some of y'all are sitting there like, well, if I plus or minus 20 inches from that, I'm getting my answer. Yes, you are. The goal here is to actually represent it as a single inequality, and that's the usefulness of absolute values. And that's the reason why we're going over that today. So it could be as low as 80 square inches, as high as 120 square inches. You could also represent it as a single inequality, which I do like to see. 80 less than or equal to x, which is less than or equal to 120. For those of you thinking that this is going to be enough of an answer on quizzes or tests, because it said write an absolute value inequality, I am looking for this as part of your answer. So keep that in mind, that I'm not just looking for the values. All right, let me know what questions you've got. Appreciate it very much.